Hey everyone, welcome back to the second half for Unit 2. We're going to start with Video 8, which is the derivative of inverse functions. And I'll take a second and explain how we arrive at the derivative of the inverse. So I'm going to use that by using two inverse functions. Now, technically, g is going to stand for the inverse of f in my problem, and we're going to let f be a differentiable function, which just means we can take the derivative of it. So, okay, the first thing that you should know is that if I do, for example, f of g of x, again, understanding that f and g are inverses, I should get x. You should remember that from Algebra 2 and pre-calculus. When you compose two inverses together, you get x. So if that's true, to find the description for the derivative, I'm actually going to take the derivative of both sides. So here I am using the derivative operator. On the left, that's chain rule. So I would have f prime of g of x times the derivative of the inside. And on the right-hand side, I would just get 1. So then if I want the derivative of what is the inverse, g, all I have to do is divide both sides by that value right here. So there you have it, folks. The derivative of an inverse function is 1 over the derivative of the original function of the inverse value. That's a lot to take in, so let's look at a couple examples. So in this first example, they give you the original function, and they tell you that they want the slope of the line tangent to the graph of f inverse. Let's just call that g to make it a little easier on ourselves. So g is the inverse of f. Okay. And they want the tangent line for g at the point 3, 1. And they said that this point is on the inverse. So note to self, this is either on g or this is on f inverse, however depending you want to look at it. So, okay, so if I know I'm dealing with finding g prime basically of 3, remember you're finding this is an inverse. So you can use the inverse rule, which says 1 over the original function's derivative of the inverse, which we call g of 3 at the value you're looking at. So, okay, that means I have 1 over f prime of, do we know g of 3? Well, we do if we know this is the point on the inverse, or on g. So that means at 3, this is actually 1. So now I'm just looking for what the derivative is of the original function at 1. So off to the side, I'm actually going to find the derivative of f, which is easy, 2x minus 1, and then I'm going to plug in 1. So my final answer just comes out to 1. If I wanted then to actually write the equation of the line, of course, I could use the point and finish it. Okay, for the second example, we've got f is defined by this square root function. The 0.53 is on f, so that's important to know. It's not on the inverse, it's on f. If g of x equals the inverse, so they're helping us out by calling it g, find g prime of 3. All right, so again, because we know that g is an inverse already, we can use the inverse rule. 1 over the original, which is called f's derivative, at g of 3. At the inverse of 3. Okay, so let's do it. 1 over f prime of, all right, well, we need to know what the inverse function's value is at 3. Well, they gave you a point on the original, and if you remember, when you have two inverse functions, whatever xy is on the original is the same as yx on the inverse, so they switch places. So if I plug in 3, I should go back to 5 for an inverse. Might take a few times watching that through to really understand that. So then I just need the derivative at 5. So that's going to take a little extra work. I'm going to treat it, actually, let's do this. I'm going to treat it like this and do chain rule. So I get 1 over root 2x minus 1 for my derivative. And then if I plug in 5, I get 1 over root 9, or 1/3. So I get 1 over 1/3, so I get 3 for my final answer. Just don't forget that when you're finding the derivative of this, you're actually plugging it back into the bottom. Some people will leave the answer of 1/3, but it's 1 over 1/3, so 3. In our last example, we're going to use a table, and I'll keep it f inverse, even though it's going to look a little weird, but that way you can see what's happening. Okay, so they tell you f inverse is the inverse of f, which is the same as the notation, and they want this. That means they want the derivative of the inverse at 2. So that's why they kind of do this, so you can see. That means I want 1 over the original's derivative at the inverse of that value. It's a little different because we're not using a g. Okay, so let's see what we can do. If I go over to my chart, if I'm looking for f inverse of 2, I'm looking for an output of f being 2. So go over to your table. Here's my outputs for f. So if I have 2, that would get me back to 1 if I'm actually doing the inverse. So this is f inverse of 2 is 1. Then I need the derivative at 1, so I can go back over here, which is -8. So I have 1 over -8 or -1/8. Okay, so you've got a lot of good examples out there to try. It's a short video. You might need to watch a couple of the things a few times to get this, and we'll see you in class.